Ratios of similitude, known as the SPAV chart. So when we dilate figures, they get either bigger or smaller. But how they get bigger and how they get smaller changes depending on which component you're talking about. So the letters in the SPAV chart stands for side, or ratio of similitude, P for perimeter, A for area, and V for volume. So we're going to take a look at each of those components and how they change when figures are dilated. In order to do that, we really need to take a look at 2D and 3D shapes first. So first, let's take a look at this square. This beautiful square, let's say, has a length of 2 inches. If I was to say, hey, how big's the side of that square? You'd say the side is 2 inches, right? Now, we'd use inches. That's the main takeaway from this. Side is in inches, right? Now, if I wanted to find the perimeter of that beautiful square, you'd say, well, then I'd need to use what I know about squares, that all their sides are the same. And I'd put 2 inches all the way around. And I'd be able to tell you that your perimeter is equal to 8 inches because 2 plus 2 plus 2 plus 2 is 8. But the big takeaway, we're still talking about inches, right? Because I can take all of those lengths, put them in a straight line, and measure it. Now when I get to area, things get a little bit different. I still know that this side is 2 inches and that this side is 2 inches. And to find the area of a figure like this, we do length times width, so 2 times 2, and that's 4. But we don't just multiply the 2 and the 2, we multiply the inches and the inches, and that results in inches squared. So area will always have a unit of inches squared. Now let's take a look at this volume. Again, the shape is now 3D, so we have 2 inches for length, 2 inches for width, and now I have 2 inches for depth or height. Now, if I was to look for the volume, it would be 2 times 2 times 2, which is just 8. But more importantly, it would be inches times inches times inches, which is inches cubed. Now, I'm sure you're probably wondering why we're talking so much about all of these inches and all the different ways they appear depending on what we're looking for. But it is quite important because in the SPAV chart, we need those units to help remind us what changes. So the SPAV chart, again, S stands for side, P stands for perimeter, A stands for area, and V stands for volume. Now the S can stand for similitude or side, but either way, if it's measured in inches, perimeter is still measured in inches. The only time that changes is when we get to area, and that's whatever our unit is squared. And V is whatever our unit is cubed. So let's look at an example. Let's say I had these 2 beautiful cones, and my original cone was 3 units high. And then it was dilated down to be 2 units high. Well, the ratio of those heights is 3 to 2. So we can use that for our S, and in this case, our S is really standing for similitude, but any 2-dimensional unit can be used here. So for example, if they gave us 2 radii, we can put that here, or the lengths of the circumferences we would put in perimeter, but any 2D measurement we can put here. Now again, because sides and perimeter are measured using the same units, that 3 to 2 just bounces over to this column. These columns are always going to be the same. But when we get to area, we're going to use that 3 to 2 to find our area by squaring each of them, the same way we squared those units. So 3 times 3 is 9, and 2 times 2 is 4, which means the ratio of these areas is in a ratio of 9 to 4, not 3 to 2. Same thing with volumes. I can use the 3 to 2, but I need to make sure that I am cubing them both. 3 times 3 times 3 is 27, and 2 times 2 times 2 is 8. So the ratio of the volumes of those 2 cones is in a ratio of 27 to 8. Now, I can't take credit for the SPAV chart. I worked with a really brilliant person many years ago, and he taught this to me. And I've used it ever since because I really do think it's ingenious. And the best part about it is you can take whatever they give you and get all the other components. So let's say they were to give you the ratios of the areas. And they said the ratios of the areas of 2 rectangles, whatever they are in a ratio of 16 to 49. You could say, oh, well, that's in the A column. How do I get back to the S column? Well, if I need to square it to get area, I can take the square root to get my side. The square root of 16 is 4. The square root of 49 is 7. I can push that over to find my perimeter because those columns are always the same. And when I get to volume, I can still use that 4 and 7. I'm just going to cube them both. And 4 cubed is 64, and 7 cubed is 343. So it's just a really genius way to organize your thoughts, and that can be really helpful in difficult word problems, especially multiple choice. So let's take a look at some multiple choice examples and go through how we can use the SPAV chart to help organize our thoughts. This is the first Regents question I'm going to talk about. It's from the August 2022 Regents, and it's number 16. I'm going to point out that there are no diagrams here, but it starts by talking about right triangles ABC and RST. So the first thing I'm going to do is draw two right triangles. They don't need to be perfect, but I should denote whatever the right angle is, and then keep reading to see if I can figure out where those letters belong. So it says hypotenuse AB is 4. So that's a big deal because it's telling me the hypotenuse of the first one is AB, which makes my right angle C, and this is 4. Now my second one, it says the hypotenuse of RS is 16. So now I have an R and an S for my hypotenuse, which is 16, which means that right angle down here was T. This is a really valuable skill in all Regents questions. So even though I'm not going to need those angles in this problem, it's a good thing to continue to practice. It then tells me that these two triangles are similar, which is a big deal because it means their sides are in proportion. And it wants to know what the ratio of 1 to 16 represents, and it gives me all those options. So I'm going to let you know right off the bat, I am not ready to look at those options yet, but now that I see ratios and they're talking about areas and volumes and perimeters, I know I'm going to do a SPAV chart. So I'm going to go ahead and I'm going to write S, P, A, V. And I'm going to organize myself by putting 4 to 16 under the side column. So 4 to 16. Now, I'm always going to recommend that if you can reduce, you do. Because if you can, you should. Is there a number that goes into both 4 and 16? And there is, 4. 4 goes into 4 once, and 4 goes into 16 4 times, which means these sides are in a ratio of 1 to 4. So it's very important to know that these are equivalent. 4 to 16 and 1 to 4 mean the same thing. It's just a matter of keeping it in simplest form. So I can knock this over and put 1 to 4 right here because sides and perimeters are always the same. And I know that my area, I'm going to use that 1 to 4, but I'm going to be squaring them both. 1 squared is 1, 4 squared is 16. And now I'm going to go over and do my volumes. I'm going to use my 1 to 4 again, but now I'm going to be cubing them both. 1 cubed is 1, because 1 times 1 times 1 is 1. And 4 cubed is 64. Again, guys, you can do that multiplication in your calculator, just 4 times 4 times 4, or use the cube button. So if I zoom back out and take a look at what they really want, I'm going to point out again, they wanted to know what would have the ratio of 1 to 16. So let's just go through it all. The legs would have a ratio of 1 to 4. The areas, 1 to 16, so it looks like that is going to be our answer. The volumes would have a ratio of 1 to 64. And the perimeter would have a ratio of 1 to 4. And again, legs is 1 to 4 because legs is just the side. So this was a multiple choice question, which really needed the SPAV chart to help us understand how the ratios of the areas scale. All right, let's take a look at our second Regents question, which is going to be from June 2015. And again, since we're getting ready for a Regents, I'm going to point out some really important skills, and that's going to be labeling these triangles with some colors. So since A and D are the letters that come first, we know that angle A and angle D are the same. Since B and E are the letters that come second, we know that B and E are the same. And we have this C here. Now, anytime I have triangles that are all mixed up like that, I do like to redraw them, and I'm going to do that in a second once I finish filling out my information. So it's telling me that AC is 12, so I'm going to put a 12 right here. It's telling me that DC is 7, so I'm going to put a 7 right here. And then DE is 5, so I'm going to put a 5 right here. All right. It then tells me that the perimeter of triangle ABC is 30. Okay, and it wants me to find the perimeter of triangle DEC. And that word perimeter is my hint. Because it says perimeter, that's how I know I'm going to use my SPAV chart. So I'll even go ahead and set myself up here, S, P, A, V, but I need to start off my chart. And in order to start off my chart, I need a ratio, okay? They gave me the sides, so I'm going to use the sides, but they gave me 3 numbers, and this is where it's really important to be organized. So I'm going to redraw my triangles. I'm going to put triangle A, B, C up here, and I'm going to put a smaller triangle down here. They don't need to look the same. It's just work to help us. But I'm going to remind myself that I made A green, so the green angle should go here. And I made B blue, so the blue angle should go here. And I made C pink, so the pink angle should go here. So when I'm writing that down, I see that D is green, so D goes here. E is blue, so E goes here. And C is red, so C goes here. Now when I'm plugging in my numbers, that should help me. AC was 12. Let's see, DC is 7, and DE is 5. Which means these two sides correspond, and that 5 was just there to confuse me. That's why redrawing is really important. So I'm going to put these triangles in a ratio of 12 to 7. So 12 to 7. Now I'm going to note that we're working with perimeter here. This is what we want for the problem. But since we're practicing, let's fill out that whole SPAV chart. The 12 to 7 ratio just slides right over 12 to 7. And then we would do 12 squared to 7 squared for area. Now the numbers are going to start to get big, but that's okay. So we know that 12 squared, it's a perfect square we should know, is 144, and 7 squared is 49. But when we get to 12 cubed and 7 cubed, that might be a little bit harder. 12 cubed is actually 1,728. Use your calculator, don't be scared. And then 7 squared we actually used before, it's 343. But again, those parts aren't necessary. We're just using perimeter here. So that was just more for practice. Now this is what's really important here because it's giving me the perimeter of triangle ABC. So I need to know that this ratio is what I'm going to be using. Now when I say using, I can put that 12 to 7 ratio in a proportion. So I can say 12 goes over 7. Just remember that that 12 was a part of triangle ABC and that 7 was a part of triangle DEF. So when they tell me that the perimeter of triangle ABC is 30, it needs to go on top. And they're telling me they want the perimeter of triangle DEC, that X is going to go on the bottom. So the beauty of the SPAV chart is you can use it to find the ratios, but you can then use those ratios to find actual values. Now I have a proportion that I can solve for X. So again, in proportions, I cross multiply 12 times X. And when I do that, I don't multiply right away. In this problem, it's not going to make much of a difference, but in other problems it does. So for the sake of consistency, I write my multiplication first. 12 times X equals 30 times 7. Obviously, 12 times X is 12X, and 30 times 7 is going to be 210. And now I'm going to divide both sides by 12. Okay, so I get X equals 210 divided by 12, which is 17.5. So that means that my answer here is 17.5. If you take a look back at this Regents, this question was multiple choice, so you'll feel a little bit better about picking your answer. But you should check to make sure it's reasonable, right? My original triangle was 30. This is 17.5. It's getting smaller. That makes perfect sense. And I just want to take a note to recognize how much work is required for this problem. Multiple choice problems are the hardest part of a Regents. They often require 2 to 3 steps across 2 different curriculums, or 2 different units, I should say. So please make sure you're taking it slow and showing all of your work. Now let's do the last Regents question. This one's from August 2018, and I love this question. Again, it's not giving me any diagrams, but it's telling me that triangle RJM has an area of 6 and a perimeter of 12. And then it's saying if the triangle is dilated by a scale factor of 3 centered at the origin, what are the area and perimeter of its image? Triangle R prime, J prime, M prime. So again, the only reason why I know to use SPAV in this instance is because it keeps talking about area, perimeter, all these letters that I know are in my SPAV chart. So let's put that down. S, P, A, V. Now, it doesn't give me a ratio. Instead, it talks about a dilation, which is how we started this video, talking about how things scale differently in dilations. And it says a scale factor of 3, which means whatever my original figure was, let's say 1, now it's being multiplied by 3. And the fact that it says the origin is the only reason why we know that. Okay, so because it says scale factor of 3, my smaller shape or triangle is going to be 1, and my bigger one's going to be times 3. That's why it's a ratio of 1 to 3. Again, we're going to remember that everything's the same except for areas squared, volumes cubed. So this 1 to 3 can come over and stay a 1 to 3. But for area, it's going to be 1 to 3, each value squared. So now it's 1 to 9. For volume, it's going to be 1 to 3, but each value cubed. So now it's going to be 1 to 27. Now in this problem, it wants area and perimeter. So we're going to do each of those separately. For the area, we're going to use our 1 to 9 ratio. So remember, I can set up a proportion. 1 over 9 equals. Now it's telling me that the area they gave me, that 6, that's what I have to decide, right? Does the 6 go up top or does it go on the bottom? And I know it's for the original triangle before everything was multiplied by 3. So it's going to go up top at that original triangle, that value of 1, right? So this was our original and this was dilated. Or pre-image and image, right? And now my x is going to go here. If I was to cross multiply, I'd get 1 times x, which is 1x, and then 9 times 6, which is 54. Or 9 times 6, put that 1 there, so x equals 54. Now just based on this, so again, this was area, we used our area ratio for this. We now know that it has to be either 3 or 4. 1 does not work and 2 does not work. So it's just a matter of whether the perimeter is 36 or 108. And I'm sure that 108 should be screaming to you right now because it's just 54 times 2. So I don't think that's the answer, but let's make sure. So when we're talking about perimeter, we're going to use this 1 to 3 ratio and we are going to set it up the same. So for perimeter, we are going to say that it's in a ratio of 1 to 3. And remember, they gave us the original triangle had 12, so that's going to go up top. Now let's do our cross multiplication. So 1 times x is 1 times x, and 12 times 3 is 36. So let's do 12 times 3, and that means x is equal to 36. So that means our answer is 3. Again, a multi-step question using the ratios in a proportion. So sometimes I'll ask you just for the ratios, other times you need to use the ratios to set up a proportion. But remember, those multiple choice questions are the hardest ones on the test. They usually require multiple steps. So let's make sure that we show all of our work, we give them our very best effort, and please check back to the channel to see other videos for helpful Regents hints.